Disk is a hypothetical megastructure. It takes its name from Dan Alderson, a former scientist and science fiction enthusiast who's chiefly credited with coming up with the concept. The disk, as a setting, has also been used in various books, films, and comic book series. But what exactly is it? Could we ever actually make one? And what would life be like if we did? Like probably the most mainstream astronomical megastructure there is, the Dyson Sphere, an Alderson disk is built around a star. It could be built around the sun, but it doesn't have to be. It could be any star. The disk is like a giant, and we really do mean giant, plate, thousands of miles deep. There's a certain distance between the star in the center and its inner edge where space exists relatively unchanged. But after that, it's all disk. Everything from that point outwards, for millions of miles, exists on this incredible wheel. From a distance, it would look a bit like a record player, but blown up to cosmological proportions. The star in the middle of an Alderson disk is the metal rod onto which you place your LPs. The disk itself is the record. In many ways, though, an Alderson disk wouldn't dramatically alter the general conditions of a star system. There would still be parts that were hotter or colder, and from the perspective of life, there'd still be a habitable zone. An optimal distance on the disk around the star where life would be most likely to form and flourish. Think of our solar system as we know it, with everything moving around our sun. Mercury is the closest planet to our star, being around 36 million miles away from it on average. So at the corresponding distance on an Alderson disk, you'd be more likely to find Mercurian temperatures before we factor in atmosphere. Earth is the third planet away from the sun, about 93 million miles away on average, and close to the center of the habitable zone. That's why it's so pleasant and possible to live here. Travel to a similar position on the disk then, and you'd hope to find something resembling Earth-like temperatures and an Earth-like environment. As humans, we'd hope to at least find somewhere where we could survive. At the other extreme, millions and millions of miles beyond this, you'd reach the outer edge of the disk where temperatures would plummet. But that's not all that would be unique to this particular part of the structure. On the inner edge, most Alderson disk designs include a huge wall. This is needed because without it, there'd be no defense against the star, and everything would just burn and melt and disintegrate. There'd also be no way of retaining any kind of atmosphere on the disk itself, so it's pretty important that you get this wall built. On the outer edge, though, there often isn't a wall. Again, designs do differ, but generally the outer edge is much less fixed. It's roughly held together through gravity, but eventually it gives way to space and the disk ends. Were anything capable of surviving here, then the ground could literally be moving beneath its feet. Gravity, in general, allows for some interesting things to happen on an Alderson disk. First of all, it would be massive enough to exert gravity enough to ensure nothing fell off of it. But also, because its mass would far outweigh the mass of the star in the middle, the star wouldn't be the chief gravitational influence. The star's pull would have some effect on the inner regions, yes, but it wouldn't dictate so precisely how things work, like the sun does for us. And then, again because of the huge mass of the disk itself, it would attract things from the top and from the bottom. So it would be possible for humans, or anything else, to live on both sides of an Alderson disk. Let's think about this in particular for a moment. Imagine that you live in the habitable zone on the disk. You go about your daily life without ever really questioning how the disk works, because that's just how it's always been. But, and even though it exists thousands of miles literally beneath your feet, you know that elsewhere on the disk, there's another spot at this exact distance from the sun. You might imagine it like a mirror image of your own location, although really there'd be no reason why this would be the case. The other side of the disk would actually have its own history, independent of your side. Its place in the universe would be very similar, but the details of how it evolved and adapted over time could be very different. The landscapes could be totally new. From your point of view on the opposite side, it wouldn't quite be an alien world, but it would be a great unknown, an exotic land. So wouldn't you want to at least visit it every once in a while? In the real world, we have bridges to connect previously unconnected places, crossing rail tracks or rivers, or sometimes whole seas of water. Now we'd need to bridge through the disk. We'd need extremely long, extremely strong, and extremely deep tunnels. Given that this entire structure is completely hypothetical, there's nothing we can compare these tunnels to. They'd all need to be much more substantial than even our deepest tunnels on Earth. But on the Alderson disk, they would be invaluable. They'd double the space available to either side, and they'd make maintaining the disk a much easier task. There'd be no nasty secrets hidden underground, for example, because we'd be able to access all layers of our world. with entrance and exit points on both sides. And ultimately, this is just one way in which life on an Alderson disk would be so much bigger. Even in just the habitable zone, there would be millions and millions of square miles more of livable, fertile land. Imagine just the orbital path that our Earth takes today. It's a distance of 584 million miles around the Sun. But on the disk, every single mile of that would be open and available to live on all of the time. Now imagine the orbital distance across the entire habitable zone, and that's what we'd be dealing with, times 2 on account of there being 2 sides. Everyone would certainly have more than enough space. But would that mean that life on an Alderson disk would also be lonely? Perhaps, because there could literally be thousands of miles between homes or cities. And it's not as though this would be the only downside either. An Alderson disk works great in theory, but what if something went wrong? Say part of the inner wall crumbled, or a massive asteroid punched an almighty hole right through it. Anything which affects the balance of an Alderson disk system, even if it only causes a slight wobble, threatens to destroy the entire thing. The wall crumbling, for example, would be happening millions of miles away from the habitable zone, but it would still eventually have an effect on the outer regions. If the star at the center of everything were to breach a weak spot in the disk's defenses, then it might burn through an entire section and destabilize the now not-so-mega structure. So when you imagine an Alderson disk, would you want to live there? Would you like the chance to venture across its sprawling zones, or through the disk itself to explore the other side? Or is the disk simply too dangerous a place, and somewhere you'd never like to call home? For now, we can safely predict that we won't be building an Alderson disk anytime soon. These things make even Dyson spheres look small. We'd need to somehow collect all of the matter in the solar system together to even begin building one. And then, we'd still need to work out how. How do you build something that's millions of times bigger than even the Sun? But that doesn't make them any less exciting to think about. And if there is an advanced enough civilization out there that really could build one, well, space would be their playground, and the disk would be their oyster. Because that's what would happen if humans lived on an Alderson disk.